America is addicted to oil, which is often imported from unstable parts of the world. The best way to break this addiction is through technology. And we are on the threshold of incredible advances. Cutting-edge methods of producing ethanol, not just from corn, but from wood chips and stalks or switchgrass. Our goal is to make this new kind of ethanol practical and competitive within 6 years.
What if America's energy problems could be addressed right here at home, on our own farms and prairies? What if we could grow our way to more abundant fuel supplies, a cleaner environment, and greater energy security? We can. Ceres, growing tomorrow's fuels today.
If oil is America's addiction, at Ceres, we believe biofuels are the cure.
There's no doubt that biofuels have a really important contribution to make to future society's energy needs.
There's a convergence of issues coming together to create an ideal environment for the development of biofuels. There are concerns about energy supply. There are concerns about energy demand. There are concerns about energy security. Finally, the environmental concerns about the use of traditional fossil fuels such as gasoline. Biofuels are fuels that are produced from plant material. What we've traditionally done is made biofuels from things like sucrose or starch. But there's a whole suite of emerging technologies that will allow us to make biofuels from things like cellulose and hemicellulose.
Starch conversion processes basically give you one sugar to ferment. That would be glucose. The difference here with lignocellulose is that you don't have just one sugar to ferment. You have 5 sugars present in plant cell walls. Where genetic engineering comes in is that there are no good organisms naturally occurring that can ferment all 5 of those sugars to ethanol.
At Ceres, we've taken the technologies that have been developed for use in the Human Genome Project, things like high-throughput DNA sequencing, microarrays, and we've applied them to plants. And we're applying them towards the development of specialty biofuels feedstocks known as dedicated energy crops. These are plants that would be grown only for the production of energy.
Alan Greenspan testified to the U.S. Senate Foreign Relations Committee. Corn ethanol, though valuable, can play only a limited role. But cellulosic ethanol would help to wean us of our petroleum dependence.
There's only a finite amount of starch material that we can use to make ethanol from, and there's a lot more lignocellulosic biomass available so that we can make a bigger dent in the oil import problem that the country faces. What Ceres intends to do is to become the major provider of seed or germplasm to farmers to generate the millions of acres of lignocellulosic material that are going to be required to make a large impact on the transportation fuel sector.
Switchgrass is a good biomass energy crop, and Ceres is committed to being on the frontiers of that endeavour. We're focused on making improvements to switchgrass, helping to increase the biomass yield per acre, increase the diversity of environments in which we could successfully grow the crops, to grow them more cheaply by being able to put less fertilizer and water and so on, and change the composition of the cell walls so that it's easier to extract sugars from them, which are then turned into ethanol or butanol.
Using advanced biotechnology methods, Ceres is doing today for dedicated energy crops such as switchgrass what farmers have been doing for food crops for thousands of years.
Plants evolved not to serve man, but to really maximize their own survival. So breeding has really been a very, very important activity for man.
Operational since 1997, Ceres is the world's leading plant genomics company. Working closely with international giants like Monsanto and fueled by over $180 million of research and development investments, Ceres technology has resulted in an impressive array of proprietary products. Today, with more than 75,000 plant genes sequenced, including over 15,000 switchgrass genes, Ceres is now at the forefront of the biofuels revolution.
Since Ceres' inception, we've discovered and characterized more plant genes than in the whole of human history. Most plants contain about 30,000 genes, but only a small portion of these genes are really important in plant growth and development and stress tolerances, traits which are real important to transfer to switchgrass. So in our high-throughput pipelines, what we're trying to do is discover all of the genes that are important in plant growth and development and stress tolerances, and then to associate markers in switchgrass with these specific genes so that we can map these traits in a breeding program so we can get higher yields faster.
The technology to produce biofuels like ethanol and butanol from cellulosic material is here today. What we need to do is drive it to be more economical. We can do this by producing the biofuels feedstocks, things like dedicated energy crops, switchgrass, miscanthus, etc., and produce them cheaper, more tons per acre. Additionally, we need to improve the processing technology, right? The enzymes that are used to break down this biomass material into simple sugars, and we need to improve the fermentation technologies, organisms that will then ferment it to things like ethanol and butanol.
The beauty of something like switchgrass or other potential energy crop species is that you can harvest much more material per acre. And what that means is that the circle from which you have to draw material around a central processing facility shrinks considerably. And that affects transportation costs, which decreases the amount that a processor has to pay for a feedstock delivered to its processing facility.
Today, new breakthrough technologies in the processing of biomass are making the production of cellulosic ethanol more affordable.
It's a very exciting time for cellulosic biofuels. The Department of Energy has authorized hundreds of millions of dollars in expenditures to improve the processing technologies and improve the fermentation technologies that will be used to make this a commercial reality. Some of the super major energy companies, Chevron, BP, Shell, they've all formed their own biofuels units. BP has announced that they're going to spend $500 million on an energy bioscience institute, again, to advance the biotechnology and the technologies needed to make cellulosic ethanol a commercial reality. So there's a strong commitment on the part of the government and by the major energy companies of the world to make cellulosic biofuels a reality.
In June of 2006, Ceres signed an exclusive long-term agreement with the Samuel Roberts Noble Foundation, the world's premier organization for forage grass research and breeding. It gives Ceres exclusive access to Noble's high-yielding switchgrass varieties and its advanced breeding infrastructure, while also creating important ties to Noble's extensive network of farmers for field trials, agronomy, and seed production.
Ceres is one of the great plant genomics companies in the world. Their proprietary genomics technologies are well regarded. What I saw that was really important and impressive to me was the chemistry between people. And I saw two organizations whose key bright people really fed off of each other, if you will. And that's the way great things happen.
Well, today, biofuels represent about 2 to 3% of our liquid transportation fuel supply. When we're talking about going to 100 billion gallons a year in 2030, that could take it upwards of 70% of the total demand. We're really addressing one of the main needs of the 21st century, which is a renewable, reliable, and sustainable fuel supply for our future. This is a market that's not going away. It's on the front end of emerging today. And if you want to ride that wave of the future, Ceres is going to be on the front edge. And we're excited about the prospects, and we're moving forward very quickly.
Ceres, growing tomorrow's fuels today.